for a project. User management is what actually owns the project because they're the end users of the project. At the end of the day, they assume ownership of the project, the resulting system. The project steering committee gives us overall direction without being a participant in the project itself. Oftentimes, these will include senior management, just as I described earlier. The steering committee will have senior managers from the business units that are affected. The project steering committee assumes overall direction and responsibility for costs and timetables of the system development projects. Pardon me. They approve acquisitions of application systems, for example. Again, just more exam-y type things that all support, again, the overall goal of project steering committee, which provides overall direction for the programs. The project sponsor is who actually pays for the project. Sometimes that's the project owner, but sometimes not. That is the project sponsor. They are ultimately responsible for providing requirement specifications for the software development project team. That's at least ISACA's feelings. Again, I would normally have said the project owner is responsible for that, but they say the project sponsor is. Going on, the project manager is who provides the daily management and leadership of the project for the project. They progress it. They make sure that we're on time and manage delays. They monitor the project and control it. The systems development project teams, they tend to complete project tasks, providing deliverables, quality assurance. That role verifies successful completion of deliverables from each project phase. The portfolio management is designed to be used and assist with the definition, prioritization, approval of running projects. Again, various terms and definitions that ISACA uses, and sometimes there's really no formal reference catalog for these things. By the way, that makes you wonder, well, where did they come from? Good question. The dilemma is this, is if you go onto ISACA's website, you're going to find that if you become CISA certified, why, you're qualified then to submit an exam question candidate, meaning that ISACA crowdsources their exam questions from everybody, from the public, so long as they're certified in that subject area. Problem is with that is, who's to say that their opinions were really correct? Well, you'd have to make sure you do some heavy-duty copy editing and verification of these things before they made it to an exam. I don't know that that always happens. So this is why sometimes you see some questions are, well, kind of sketchy, to be honest. Understand that ISACA often doesn't author their own questions. They crowdsource them. It's right there on their website. You can find it yourself. So going back to portfolio management, again, what should you review to gain a better understanding of the effectiveness of controls over the management of multiple projects? Why, you would look to the project portfolio database for that. So just like I explained to you at the start of the day, that this project life cycle would come back to us, not just in managing an information systems audit, but actually in performing IT management, which is what we're looking at now. So when it comes to project planning, ISACA recognizes that estimating time and resource requirements for individual tasks is often very difficult, especially when you're doing software development. So this is where we have to try to get an idea of what is the size of the software development project itself. We might look to try to determine how big is the software package. How many lines of code will it be? How many interdependencies does it have? And so on. So again, ISACA is saying we can look to lines of source code, or we could employ something known as function point analysis, or FPA. That's a technique for estimating the size of a system to be developed. As opposed to an FPA is not used to determine project duration, we would use a PERT chart for that, Program Evaluation Review Technique. Again, that considers different scenarios for planning and control projects. You'll need to know which tool is used to accomplish which need. So, for example, if we want a tool for scheduling project tasks, we would use a Gantt chart, and that helps us progress the entire project. We have something known as critical path methodology, and this is where we figure out our critical interdependencies between processes so we can determine what we need to do first, before second, before third, and so forth. That's our critical path methodology. It's described as the longest duration path through the work plan, meaning that if anything on that critical path line becomes delayed by even a minute or a day, since everything else beyond that process, that deliverable, relies on its completion first, any delay at any one of those critical path items increases the duration of the entire project. So this is why it's known as the longest duration path through the work plan. Activities along the critical path are known to have zero slack time, meaning if they're delayed by a minute, that is noticed because it ends up delaying everything else a minute. Again, we have to identify our critical path, because not only is it the longest duration path through the work plan, but also, and as it becomes longer, so does the entire project. But that means that we'll never get the project done sooner than that either. So that is the project's earliest possible completion time. We'll use earned value analysis to measure the project's progress in terms of time, budget, and deliverables. And ISACA wants you to know about your magic triangle here of a project, understanding that as we change the dynamics of costs and resources versus deliverables versus duration, if I put less money in the project may still complete, but it will take longer to do. So in other words, if I pinch on one corner, it comes out on another corner. If I end up putting more money at something, I can shorten the duration and increase the deliverables. Well, in the end of the day, what is your exam question? If you're reviewing a project where quality is a major concern, you could look at the project management triangle to show that an increase in quality can be achieved even if resource allocation is decreased. What? Better quality at less money? Yes, it's just going to take 25 years to do it. That's all. Oh, well, we don't have that kind of time. Well, then we got to go back to the triangle. By the way, ladies and gentlemen, that goes back to, we say you can have it good, fast, or cheap, any two of the three. You want it good and fast, it won't be cheap. You want fast and cheap, it probably won't be good. It's the project review triangle. So, systems development controls guidelines. Who is responsible for designing, implementing, maintaining a system of internal controls? That would be management, not senior management. Again, trying to make sure that controls satisfy a risk issue. Remember when I told you that a risk assessment is what is used to determine, the need for a control or the control objective that we then try to measure the control against with compliance testing to see if the control works to fulfill its control objective. So as compared to control goals and objectives, again, application controls most directly apply to what? Mitigating the impact of discovered exposures to risk. It's a pretty cumbersome, awkward way of saying that application controls address vulnerabilities, especially when they use the term impact. If you actually study formal risk management with me, you're going to see that there is some improper use of terms and definitions in the ISACA exam, but it is what it is, and it's their test on test day. Systems development and controls guidelines. As we look at this, again, these are just examples that we need to memorize for the exam. As it comes to developing systems and in those projects that are related, we need to make sure that all necessary controls are included in the initial design, which means that we address security even during the planning phases of a software development project. What do we use to graphically summarize? Data paths of storage. Those will be data flow diagrams. Then we get into a lot of different kinds of controls. Now, ISACA on the CISA exam, what they've done is they have input controls and processing controls and output controls and integrity controls. So rather than mix them all up, I like to have things organized into drawers in my mind, into folders, if you will. So what I did is I took all of their controls and I gathered them into common groupings. So for example, If ISACA is asking me a question about trying to take care of some kind of data entry or data acquisition risk, I'll realize that that's an input control risk. And if I've memorized which controls are input controls, which controls are output controls, well, I could look through those answers and I could scratch out the output controls immediately. Matter of fact, I may find that I only have one input control on the whole list of answers. And if the question is going towards a data entry issue, why, it has to be an input control. So I'm using these kinds of tricks to help me make sure that I stay on the right path to succeeding on the exam. So I've put all of your system's input controls into the same category. Different types of input controls. We have a reasonableness check. That's making sure that we use some kind of data validation check to make sure that the input matches to an occurrence rate, that if it's supposed to be a positive value, that it is a positive value, things like this. We can use key verification. This is where one employee enters an amount or some data into a field, and then another employee re-enters the same data again. Hey, aren't we kind of already doing that when we set up passwords on any kind of web account? Yeah, you have to put in your password twice. That's key verification. Limit checks are another type of input validation check that provides a preventive control to make sure that invalid data can't be entered because, well, maybe the data has to be between certain limits. For example, if it's going to be, they have to enter the day of a month in a given field. Well, we know it can't be over 31 and it can't be less than 1. So we can set a range check on that, a limit check, if you will. So we have table lookups trying to prevent any kind of undefined data that would be entered. Again, if you're going, I've never heard it called a table lookup before. ISACA has their own terms and definitions, probably submitted to them by the public at large. So there it is. Completeness checks ensure that all the characters are required for a field have been input. Again, making sure, for example, that a date is a complete date, for example. A completeness check used to determine also if a field has been left empty. That could be something that we check for as well. Parity bits. The reason that's not actually a systems input control at all, it just sounds very, very similar, so I like to put them side by side. If I'm looking to do a completeness check to make sure that all of my data is there in a form, that's a completeness check. But it turns out later, tomorrow, when we get into network security, we're going to be concerned that in a data transmission, what happens if some of the data packets are dropped or lost and we don't get all of the data to make it to the other side? It turns out that we aren't going to use a completeness check for network traffic. There we're going to use something called parity bits in the network packets themselves. I say that because completeness check goes to data management and forms. Parity bits goes to completeness of data transmission in a technical sense tomorrow. Because I have so many people that confuse the two, I like to put them side by side so they can see the differences between them. An existence check is a type of completeness check, again, validating to make sure that data has been entered as it should be. Wait a minute, Alan, so sometimes they call it a completeness check and sometimes they call it an existence check? Yep. But they're pretty much the same thing? Yep. One is more comprehensive than the other. Completeness check could be that there's partial data there, just not all the data. Existence is field not empty, that kind of thing. Validity check is again, entering data for agreement to predetermined criteria. So for example, if you ever tried to do a password reset, but it doesn't recognize your email address as any valid account, well, it's validating your email address against its own understanding of its accounts first before it even determines whether or not your request for a new password reset would even be valid. Pre-recorded input, think of invoice numbers, making sure that we have invoice numbers that are predetermined and automatically entered so that way we can never have confusion on invoice numbers, for example. A transaction journal is what provides information for detecting unauthorized input from a terminal. We're still on systems input controls. We have a check digit, which sounds kind of like a parity bit, but it's different. Instead of having a parity bit or calculation on network transmissions, a check digit is actually a numeric value that could go on the transactions themselves that are being recorded. So again, this is where think of it's basically a way to calculate a hash value to make sure that our data is accurate and has integrity. A check digit can be used by a bank to make sure that we have correct account numbers assigned to customers, for example, making sure that it helps us avoid transposition, transcription errors. We are now leaving input controls, ladies and gentlemen, to processing controls. So again, if it's an input question and I see a processing control as an answer, I'll know that it can't be. If I see a processing question, I'm going to get rid of my input control answers because they can't be. By organizing things in that way in my mind, I never have to debate on it later. I'm able to quickly cast out the wrong answers, leaving me with fewer potential candidates for right answers. And ladies and gentlemen, it is that kind of method that gets me out of the room first, usually. It's not necessarily me being smarter, it's just efficiency, that's all. So, processing controls, such as run-to-run totals, ensure the completeness and accuracy of accumulated data. So now we know a run-to-run total is considered a processing control. And again, I just give you more examples of how they might refer to run-to-run totals there and processing controls. We have another method to prove accuracy and processing of calculations is to have simulated transactions. Reperformance. That's a technique used to validate the accuracy. In other words, you calculated it once in the system. Let's go back and do it ourselves manually and see if it adds up. That's called reperformance. It was a new one for me, but they say it's so. And that's the correct answer on exam day. So we're still in systems processing controls. We have a sequence check. Again, that's the continuity and serial numbers. For example, if I see higher invoice numbers with dates that are earlier than previous invoice numbers, that would fail my reasonableness check, and it's also failing my sequence check, for example. So, sequence number in SAM helps verify an instruction was not duplicated when transmitting a payment. Systems processing controls, we use something called automated systems balancing to ensure that transactions are not lost during processing. We're still in the processing controls. When two or more systems integrated, we recognize that input-output controls should be done when and where on the system sending as well as the systems receiving. Going on to now, we are now into leaving processing controls, going into systems database controls. So again, concerns that we have with systems databases is potentially that we're doing distributed processing between and involving multiple servers, all in conducting one transaction process. And because of this, we have potential failure points of communication between those servers, and that could cause us to have suffer a loss of data completeness is the concern there. Remember I mentioned acid test previously. Now we're talking about database controls, which kind of makes sense because that's the category that we're in. And I said, if I inject a transaction, as a test, let's see if the system will write a check to Mickey Mouse for $1 million. The problem is reversing that transaction back out of a transaction database is very difficult because I'm about to show you something called durability. And that means once committed to the database, it will survive and stay there. That's why we typically want to be able to void invoices, but we can't delete invoices. So we want to make sure that whatever transaction, at least with financial transactions, supports ACID. And what is ACID? That's an acronym for atomicity, the principle that data integrity is maintained by making sure that a transaction is either completed in its entirety or not at all. This means that if we have multiple servers, multiple systems, multiple people involved in processing a single transaction, if that transaction breaks down in midpoint somewhere in this process, we want to be able to back that transaction back out of the system because it was incomplete, and we don't want it to be committed to the database. So consequently, we find that in order to support atomicity, we're going to have controls that come into place, meaning that if we're going to all work on a transaction in sequence together with our systems, the data was acquired here, it was initially calculated there, it was sent off to a bank for approval there, and then it was approved and then submitted to batch processing there, and then finally got reconciled at the end of the day over there. There's a lot of things that could break down in that chain. We don't want to record it as good and done until it's really good and done. And until that point, each point along the path needs to maintain kind of a record that it's a temporary transaction in progress, a checkpoint, if you will. So that way, if it doesn't hit the end of the path and finally complete successfully, we need to go back and reverse the transaction back out of the system because it never was completed fully. That's atomicity. So again, we have examples here that you can memorize for your exam. Commitment and rollback controls I just described ensure that the integrity of transactions are maintained, because that means if the transaction can't be completed in its entirety, we can roll it back out of the system. Consistency. This means that all integrity conditions in the database be maintained with each transaction, meaning that we don't have different versions of the same database that don't agree with each other. Isolation, ensuring that one transaction doesn't affect or break other transactions. That keeps our database in that consistent state. And then finally, durability. Well, this means that if I finally do have a transaction that does get completed in its entirety and is ready to be recorded and archived for posterity, well, that's going to mean that at the end of the transaction, we're going to issue a commit statement that goes back through all those servers involved in that transaction saying, hey, that temporary checkpoint that you had for that transaction, don't need it anymore. Transaction is good. It is locked in. It is completed. We will not be reversing this transaction now or evermore. So when you issue a commit statement, and again, it's not a verbal thing, it's between systems. When that commit statement goes back through the servers, they will commit that partially processed transaction and say, it's done. Now then, once we issue that commit statement and we record it as permanent, my friend, it's permanent. Durability ensures that when a transaction has been reported back as committed and complete, any resulting changes to the database survive subsequent hardware or software failures. And from a transaction standpoint, they can't be removed. In other words, you can void the transaction, but you can't delete and remove the transaction. For example, you can void the invoice, but you can't delete the invoice and have it reissued with the same number for something else. So again, that's durability. Atomicity, consistency, isolation, durability. That's the ACID principle. You may get a question on that in your exam. Database integrity, again, this is what we do, database integrity testing. We're testing the accuracy, completeness, consistency of data. Again, we're now looking at, different types of controls and tests. We already looked at controls previously. We're looking at different types of testing now. We can have a redundancy check, looking for transmission errors, again, by appending calculated bits onto each segment of data. What kind of bit? Could it be a parity bit? Yes, it could. And again, that would be at the OSI layer 2 data segment layer. So going on, data segments, packets, frames, and bits, right? Encapsulation. So database integrity, we perform table link reference checks to try to determine any kind of inconsistency between references between linked tables in different databases. A domain integrity test is used to bear out effectiveness of edit and validation routines. What detects the modification to sensitive data by use of control totals? That would be relational integrity testing. A lot of memorization in all of this, isn't it? So, again, we have control totals helping ensure that batch data is completed properly. Again, just more exam-y type stuff that you need to memorize for your tests. What testing ensures that data exists in the parent or original file before it exists in a linked child or another file? That's called referential integrity testing. If you're saying, I'm not a database person, Alan, you're losing me. Well,